Hello, grade 12. In today's lesson, we're going to be looking at physical properties and we are tackling question 3, Prelim Eastern Cape 2022. And let's get right into the question. Now we have 3.1. It says the graphs below show the boiling points of straight chain primary alcohols and straight chain ketones with different number of carbon atoms. As we can see from the graph there, we are given boiling points in the y-axis and the number of carbon atoms in the x-axis, starting from 3 to 5 and to 7 carbon atoms. Now, 3.1.1 says define the term boiling point. You can see that we have so much of that definition. That means you need to know it. It is very crucial. Boiling point is the temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. Now 3.1.2 says explain why the boiling points of alcohols increases as the number of carbon atoms increase by referring to type and strength of intermolecular forces only. So you need to note that so that you know that you answer the questions correctly. So here we are referring to the type and strength of intermolecular forces only. Now explaining that, we'll say alcohols have what? Hydrogen bonds, which are the strongest intermolecular forces. Then the strength of the intermolecular forces of alcohols increase as the chain length increases. So we are saying the longer the chain length, the stronger the intermolecular forces. Thus the boiling points will also increase. Remember, if the intermolecular forces are stronger, then also the boiling point will be higher, right? Then 3.1.3 says explain why the curve of the alcohols is higher than that of the ketones. Now we refer to what? The type and strength of intermolecular forces involved. So again, we are speaking of the type and strength of intermolecular forces. Let's explain that one. We say ketones have dipole-dipole forces, but alcohols have what? Hydrogen bonds. Now, hydrogen bonds are stronger than dipole-dipole forces. That means more energy will be required to overcome the intermolecular forces in alcohols than in ketones. Thus, alcohols will have a higher boiling point, which is indicated by a larger curve than the ketones. Now, the vapor pressure of the alcohol is compared to that of the ketone at the same temperature. Now, 3.1.4 says, why must the alcohol and ketone, which are used for the comparison, have the same number of carbon atoms? Why should they have the same number of carbon atoms? We say so that we have a fair comparison and reliable results on the investigation. Remember, whenever we are investigating this, we are trying to have one independent variable. We are only investigating one factor. So the factor that we want to investigate here is the functional group or the type of intermolecular forces that are involved there. So we should keep the other variables constant. Three 3.1.5, which one will have a higher vapor pressure? Is it the alcohol or the ketone? Now, how do we explain that? We say it's the what? It's the ketone. Why? Because it has a lower boiling point and thus will have a higher vapor pressure. You will remember that we said boiling point is inversely proportional to vapor pressure. And if you look at your table here, you can see that the ketones, they have a lower boiling point as compared to the alcohols. So the ones with lower boiling points will obviously have higher vapor pressure. And that's how you could have measured the question. Now 3.2 says the boiling points of propanoic acid and propan-1-ol are compared. 3.2.1 says which compound has the higher boiling point. Now we are comparing propanoic acid, which is from the carboxylic acid, and propan-1-ol, which is from the alcohol. Now, you will remember from our notes that we said propanoic acid and that we said that the carboxylic acid and the alcohol have hydrogen bonds, right? But then what is the difference here? The carboxylic acid has two sides of hydrogen bond, but propan 1-ol has only one side of hydrogen bond. So that means the intermolecular forces are stronger in the carboxylic acid since it has two sides of hydrogen bond. If the intermolecular forces are stronger, that means the boiling point is higher. So which one has a higher boiling point? It's propanoic acid, right? Because of the two sides of hydrogen bonding. Now 3.2.2 says explain the answer to question 3.2.1 by referring to what? The type, the strength of intermolecular forces, and also the what? The energy. So here we are speaking of three things: type of the intermolecular forces, the strength of the intermolecular forces, and the energy required, right? Now we say propanoic acid has two sides of hydrogen bond. Remember carboxylic acid, and propan 1-ol has only one side of hydrogen bond. The intermolecular forces, which are your hydrogen bonds in propanoic acid, are stronger than those in propan 1-ol. Therefore, more energy will be required to overcome the intermolecular forces in propanoic acid than in propan 1-ol. Thus, the boiling point of propanoic acid is higher than that of propan 1-ol. And that's it for this question. Please subscribe to the channel and hit the bell icon to be notified of every video I post. All the best, grade 12s.